So the other day I was looking at the QUIC transport protocol, and I was curious to learn more about how it works and what it can be used for. Um, so we already see it's implemented in Firefox for HTTP 3, and it's powering um, more and more of the web now. But the cool thing about QUIC is that it's not just for HTTP traffic. You can use it for a lot more. It replaces the typical TCP TLS stack. Um, so I wanted to learn about more applications and see if I could have a go at making one myself. Um, so I started reading the RFC. We see it's still proposed. It's not official yet, but despite that, it's far along enough in its progress that people have started using it in real applications because it's just good enough. But the specification is kind of complicated. There's 22 sections in the RFC, and you can see the scroll bar. It's quite a long document. So I'm not gonna learn how QUIC works by reading the RFC. Just too much to go through. Instead, I want to make something using QUIC. So I was thinking I wanted something that would take advantage of some of QUIC's unique features. One of the features is that QUIC is a multiplexed transport protocol. So TCP, you would have one connection and you can do one request at a time. Now, of course, HTTP 2 implemented multiplexing on top of TCP, but QUIC has multiplexing built into the protocol of transport rather than the application layer, which means your application layer does not have to worry about multiplexing, but the transport protocol does it for you, which makes it much simpler to build a multiplexed transport protocol application layer on top of the transport protocol. So I was thinking of software that needs multiplexed connections, and my mind immediately went to RabbitMQ. The RabbitMQ or AMQP protocol. It is a message queue and message broker protocol, but I remembered from when I used to use it that it has, goes to the bottom of this page, it has a connections and a channels abstraction, which is a way of having multiple simultaneous requests on a single connection, and you see they are also multiplexed, which is exactly what we're looking for with QUIC. So I thought I'd have a go at building a RabbitMQ type clone on top of QUIC. And to further make it more interesting, I want to use MTLS to authenticate. So mutual TLS, where you have both the client and the server have a certificate to prove who they are. And that way we don't have to worry about passwords or usernames or anything like that. So I said that I'm not going to read the QUIC specification, and so I'm not going to implement QUIC myself either. I'm going to use Quinn. Quinn seems to be a pretty good implementation of QUIC. There is also Quiche by Cloudflare, but I think for this I want to use Quinn. And then Quinn also uses RustLS for its TLS, which is here. And so we'll have to do some of that too. So let's just get straight into it. So I've already set up a little project. There's a simple structure. There are some complications that I've done already because they're just difficult. So I know that RustLS is a bit of a pain. So I copied this in from a previous project. Just some setups of client and server config. And then also I have a generator for some certificates that generates a certificate authority. It generates 2 certificates for the client and server. And then it also signs them. So that's the full MTLS certificate setup. And then in these, in the structure, I've got a library. This is the client library. This is what you would import into your client application. Currently, there's nothing apart from this TLS module. There's a server binary. This will be the message broker itself. And then there's an example client, which is where we're going to be testing how the client works when imported. And in this, I've only just set up the TLS stuff. So nothing extra. So I think for now I can close this rust.ls docs and we can go straight into QUIC. So there's a lot to look at here, a lot of stuff to read. But I think I'm just going to read this line. The entry point of this crate is an endpoint, and then I'll just go there. So I'm seeing a server function that looks like what we want. Let's start with an endpoint server. And the config, we need a server config. Okay, and we need the crypto. Okay, so that's what I have created above. And then we need a token key. What is a token key? Okay, we can skip the token key using the with crypto function. That makes it a bit easier. Cool, that's happy. And then for the server, we need the server config and an address. So I'm going to take the address with a port 6789, and I'm going to pass that. And okay, server returns a result. Okay, and then I'm going to rename this now, it's not unused. Okay, we have a server. That was easy. Let's do the same for client while we're here and see what this ends up doing. Okay, so we create the endpoint with the client socket address. Now it says that you should just bind it to 0, so it chooses a random port. So let client equals endpoint client Okay, cool. Now, what can we do with these endpoints? So we can accept a connection. And it says from a client, so I assume this is on the server. So let's try that. Server.accept. And that's a feature, and it returns an option. Okay, so none of the endpoint is closed. Okay, so let's await that as I assume it's going to be used in the loop. So while let some connecting equals that, and then we've got a half connected connection there. So then let connection equals connecting dot await, and that's a result. So we need to handle that. No, I'm not going to just return here with the. Actually, yeah, I will for now. It's fine. And then once we've got a connection, what can we do with a connection? With a connection, we can open streams, we can accept streams, and we can read some packets, and we can close. And we can get like IP info. we can get latencies and statistics. Okay, so let's, for now, just output some debug info about those connections. So print line connection dot stats. And these will implement debug, I assume. Yes, okay, great. And then we're gonna, I assume this implements drop to close the connection. Maybe not, maybe internals implement drop. Connection ref, yeah, that probably does. In fact, I can probably read the docs. Okay, if all references to a connection have been dropped, then the connection will automatically be closed. And I also noticed that the connections implement clone, which makes it easy to share a connection throughout your application. Okay, easy. So let's do that for now, and then let's just drop it immediately. And then on the client, let's do something similar. So let's go back to the endpoint and let's see what we can do. So we've got connect. And we've got connect with. So we haven't set up a client config yet. We haven't set up this into the endpoint, so we probably need to do that. So let's create the client config. And that just takes in our client crypto config. And oh, this needs to be the client. Okay, there we go. So we've got our config, our endpoint. We can set a default client config. Okay, that's probably a good thing to do. Client.set default client config. Leave our config. And then we can do client.connect. We're going to connect to loop back to our port of 6789. And we need to specify a server name for the TLS negotiations. So I set the server name to be server.broke by QUIC. And if we can experiment, but if I change that, that would likely error. Okay, so that connecting equals this. I need to pass this one. Okay, then we got a connection just the same. And I think we can print the same stuff on the client. And then both sides will exit. Okay, so now we have some stuff set up. Let's see if this works. We're going to run the server, and it's running. And let's run the client, and then we see some stuff being printed. A lot of noise here, but we can see a round trip time of 3 milliseconds. 2.2 milliseconds on the server. And then we can probably run the client again, actually. And then we can see, yeah, more stuff on the server. That seems to be working. We have connections being handled. Let's stop this. And let's spawn out the connections into tasks so they're actually handled properly. So I'm going to do Tokyo spawn handle connection connecting. Now, before the connection even happens, we can log some IP info. So let's do that. So we got remote connecting dot local IP remote address. Let's do remote address. So we can spy on who's sending requests. And then we await the connection. And is error about? Okay. So I also don't want to have this handler of connection function return an error. I want it to handle errors itself. So I'll have an inner function that's going to return a result. So that this one can use question mark operator and this one will handle the errors. Okay, so now we've got a connection. We should probably accept some connection streams on this connection. So let us copy this out again, and let's rename this to handle stream. And if we look at a connection, we had other accept functions, unidirectional and bidirectional. Let's go with a bidirectional stream for now. I think that makes the most sense. I'll copy this into handle connection. So accept some stream. What does this return? It returns a result with stream info. Oh, we want the bidirectional one. Okay, so it returns a result. So while that stream equals connection dot accept bidirectional stream, we will handle that stream. Okay, I've got them wrong. Send stream, receive stream. now we've got some streams, we can do something with them. For now, I'm not going to do anything. I'm just going to exit the stream. We can figure out what to do with the stream after we test the client connects with a stream properly. Yes, we are using while let incorrectly. Let's use a loop. There we go. That's better. And then, okay, that's correct. Okay, so we have the server accepts a connection. We handle the connection in a task. Then that connection is established. The stats was too noisy, let's not output that. Now we have a stream, which we accept, which is bidirectional. And then we do nothing with the stream. On the client, let's do similar. We've got our connection established. And now on the connection, we can open a bidirectional stream. And I assume that returns the same. Yep, send and receive. Okay. So now we should be able to see if I add a print line here, new stream. And is there any info on a stream that I can get? A stream ID. Okay, great. Okay, let's test this out then. Run the server, we get nothing. Let's run the client, and we see connection established, new stream, client bidirectional stream 0, and the server has a timeout. Okay, that's interesting. So it's possible that on the client we need to do something similar to as the server, where we might need to spawn some things into a Tokyo task that don't block each other. Now, I'm not sure where we need to do that, but might be what's going on. I'll just sleep for 10 seconds for now. And I think I will put a sleep after the connection is established too, of 5 seconds. And I think I'll put one just after we create the connecting as well. No, I don't think that would do anything. Okay, let's do it there. Okay. Run. In the client, we're going to start and look at the server. We get a connection. Client creates a stream, but the server doesn't see it for some reason. And the client is still there, but the server says it timed out. So what's going on there? I'm not sure, but maybe let's just try send some data over the stream. Maybe that will just get it to kick into action a bit. So let's do read to end. I need to give it a size. Okay, let's give it a size 128 bytes. That needs to be mute. Let's turn this into a string. And then let's print that out. And on the client, let's similarly send some data. Write all hello world. This needs to be mute. And let's get rid of the sleep. So maybe sending some data will cause the actual packets to get sent to the server, so the server actually sees the connection stream. Because perhaps the stream just isn't getting sent because there's nothing to send. Okay, so the client establishes, we're going to wait 5 seconds. It sends some data and then it closes, and on the server, we don't see anything. Okay, there is something going wrong here. Very strange. Why are we not getting any action? Okay, endpoint, let's go to connection. So it's possible we need to set some stream limits. I wonder what this defaults to. This is proto connection from Win proto. Connection. Actually, maybe there is just a function to read the current. Maybe not. Yeah, well, this is interesting. So let's try send from both just to see if that works. And then so once we receive from this one, we're going to send some data back. Okay, let's see. Maybe this will kick it into action. So it creates a stream, hasn't done anything yet, it's waiting. Okay, so the server has seen the stream now, but now it's getting stuck. Okay, yeah, read connection timeout. Okay, so that's some progress. The server, yeah, client has connection lost. Okay. Why is this happening? That's very peculiar. We have our streams, and then we're going to write to them asynchronously. Let's do something like this. Okay. Server, run. It's still running. Okay, client, run. Server sees the new stream. Yep. And the client is still not doing anything. Okay, that is peculiar. Yep, still getting timeout. Still nothing. Okay, that is peculiar. But I think we're getting somewhere anyway. I think I'll probably need to read the docs a bit more to try and figure out what is going on with these connections. Perhaps there is an example in the repo that we can read up on. They set up certificates, set up the crypto. They have the server config. They use the with crypto function as we do. Okay, they do set some info. And they create the endpoint. And then they are spawning off this handle connection as we did. They just did it in a slightly different way, but same idea. Now with their connection, they await the connecting to get the connection. They accept the bidirectional stream. And they spawn off the stream handler, just as we did. And then when they handle, they do a read straight away. Okay, so that is, I'm going to stop reading that and I'm going to look at the client code to see what else is different here. Okay, so they set some ALPN identifiers, so that might be important. Let's see what the server did for ALPN. Okay, yeah, that is something I haven't configured. Okay, so okay. So I'm going to call it EBQ. Okay, and I'm going to do the same for the server. Oh, client, sorry. Okay, maybe that will help on the server and the client. No, same situation. Let's keep reading on the client side. They connect. This is what we did with the host. They opened a bidirectional stream, as we did. Then they write some bytes, as we did. Ah, okay. Flush, of course, we need to flush. Let us try that now. and the server probably needs to flush too. Let's do that. In fact, I think we can just finish. Server, let's run the server. Run the client. And we have our data. Very good. Okay, so that was all we needed to do. We just needed to flush the buffers. But great, I think that is a good point to end off. So we've got server code, we've got handling connections, we're handling streams. We've got some client code that is similarly handling connections and streams. And so we can imagine that we can then, with those streams, we can implement these channel concepts. So next time I will try and build an application layer protocol for a channel message so that we can have some kind of message broker action. Anyway, thanks for watching.